Hello and welcome. I'm Marcus, and I'm demonstrating the BlueLink smart home app.
This project aims to create a scalable and cost-effective modular smart home system that integrates Bluetooth and Wi-Fi for communication.
We'll start off by looking at these two master Wi-Fi nodes. These are in charge of transmitting Wi-Fi communications from the Android app to the Bluetooth devices seen on the right.
Looking briefly at this hardware slide, we can see that this project requires ESP32s, sensors, and actuators. The software involves taking commands from an Android device, forwarding them through a master device into a servant device. Some of the main problems I addressed in this project is maintaining a persistent connection and getting reliable data from each ESP. BlueLink leverages both Bluetooth and Wi-Fi for communication, enabling energy-efficient device control alongside robust remote monitoring. The modular design allows users to expand their system without depending on external companies. In the future, I plan on implementing security and camera features.
Moving on, we'll start with the Smart Socket feature. This is a simple ESP-controlled relay that can be used to turn on and off any device such as this lamp. Moving on, we will look at the LED strip. From here, you can choose any combination of RGB colors and set the device to display that color. I can try some red here, and I can tone down the brightness. Moving on, we will look at the thermostat. This is a remotely controlled thermostat, and you can see the temperature values displayed here on the OLED screen. The temperature is reflected here on the app, and we can adjust the desired temperature for where we want it to be set. The nice part here is that the app will tell you whether it's cooling down the system or heating based on where you want your desired temperature. Moving on to air quality, this tests for hazardous gases in the air and also CO2. We can see here that the OLED display agrees with the air quality monitor on our app. There's a slight delay between the two. Now what we can do to test it, I'll quickly breathe on the monitor. And from here you can see a significant increase in the amount of CO2 detected in the air. Moving on, we have the water detector. Now this can be used to detect a flood or a leak in your household, and it can detect the conductivity between these two terminals. If I'm to just lay my hand on it, you can see in the OLED screen it updates, and we get a conductivity water accumulation of about 30 to 40%. If I take some water here and put it on the sensor, it updates to almost 100, indicating that there's water present. Once I clean up the water off of the sensor, we should see the percentage completely return to normal. After this, we can look at the connected devices list. Now, this will show all of the devices connected on the network and which Wi-Fi node they're connected to. This will be useful for if you integrate a bunch more devices and want to create a distributed Bluetooth network. From here, we can see that the thermostat, water sensor, and LED strip are all connected to Wi-Fi node 1. Here's something interesting we can do here. If I disconnect LED strip and navigate to this again, we get that the LED strip has disconnected from Wi-Fi node 1 and has reconnected to Wi-Fi node 2. Now that it's reconnected, let's go back to the LED strip feature and see if it still works. Turns on blue, and we've shown that this system can reconnect its devices once it's encountered an interruption. It can access this device by either of these two Wi-Fi nodes, and the functionality remains consistent. Here's a quick look at my sources page. Thank you very much for listening.